And with that, we will go into the cross-examination, my favorite part. So we will let Standing for Truth start with the cross-examination. So we'll keep going in the normal order. And this will be 10 minutes. So this will be for each. And I am starting the clock. Standing for Truth, if you are ready, the floor is yours.
Okay, awesome there, Adam. Thanks for your rebuttal there. I guess my first question would be, because you talked about gene duplications and beneficial mutations, and I guess how many, if we were to look at numbers, how much gene duplications and say beneficial mutations are actually needed, per year for millions of years to account for the the massive amount of living organisms that we actually see today. Because obviously just, claiming gene duplications can add the necessary novel information to the genome and can be beneficial enough to outweigh the genetic damage and take your fish to fishermen. Is there a paper that would detail, retrodictions on those numbers, or is it just more so a guess? Go ahead.
Well, you could look at the changing rates of DNA, and you can look at the divergence between, say, if you want an example of fish to humans, you could get your average fish genome compared to a human genome and say that's how different it is, and this is how we often, this is the rate at which we think these mutations occur.
Well, I think, keep going. Sorry, I didn't think you were done.
No, I'm done.
I think more so what I'm referring to would be like, even if we look at, say, Haldane's dilemma, like we know that a leading population geneticist, realize that even if there was an abundant and ongoing supply of, say, these beneficial mutations, natural selection must be very limited in its ability to amplify, right, such mutations to the point where they're actually fixed within a sizable population. So if you're going to, say, use gene duplication as your main mechanism for this large scale innovation, are there numbers, are there predictions, are there retrodictions, or is it just more of like a hypothetical or like an educated guess? Go ahead.
I think what you're asking me is, do the beneficial mutations account for us being here, despite? I'm not too sure, really.
Well, because if we look at genomic data, I'll try and make it a little more clear, right? Genomic data tells us that, well, we obviously know that the human genome is profoundly different than apes. So based on, let's say Haldane's dilemma, for example, there would need to be tens or even hundreds of millions of beneficial mutations that arose and then went to fixation during this time frame, right? So that scenario would require roughly, say, 1,000 independent beneficial fixations per generation. So according even to Haldane, that was almost an impossibility. So how is that resolved? Like, is there numbers? Is there any retrodictions? Because I guess that's what would make it scientific, right? Testable, falsifiable. Oh, can you hear me, Adam?
Yeah, I can hear you.
Like, do you find that Haldane's dilemma, for example, the problem of beneficial mutation fixation, I mean, is that resolved with actual scientific data, scientific papers, or in what you're saying in regards to, say, gene duplications, beneficial mutations, are there specific numbers? Are there papers out there that would break that down for us?
I imagine there could be. I invite you to go look for them.
Okay. If in regards to like building the genome, building that information that you're talking about earlier, I wasn't specifically referring to abiogenesis, but I did catch a few things on what you were saying in regards to DNA origins. From what I understand, evolution itself never actually predicted the RNA, DNA, protein system. And I think you said RNA evolved first, correct?
That's the common consensus, that RNA came before DNA, yeah.
So it sounded like you use a lot of, magical words like, probably, say, when explaining the RNA origins. And then obviously if we're talking about testable, falsifiable science, That doesn't seem like it'd be science. Like, are there testable predictions and retrodictions on DNA origins? Selection pressure, for example. Are there actual numbers, or is this RNA, DNA, protein system, the evolution of DNA origins? Is this also more so like an educated guess?
The reason I spoke about it is because you brought it up in your rebuttal, so I felt the need to reply to it because you asked for it specifically. Aside from that, abiogenesis isn't my area, so my knowledge is to the best of it, and we're still not too certain on abiogenesis. So that's why I'm using deliberately vague language rather than saying this is fact.
And that's understandable too. I appreciated your responses there. Let's say with DNA redundancy, right? How did because we die without DNA redundancy. We know it's really important. How did evolution, know we die without DNA redundancy? Since evolution, natural selection looks at the short term, how did that evolve? What was the foresight in something like that?
I'm not too certain on that. What, DNA redundancy?
Yeah, just all the redundancy that we actually see in the genome. I mean, would you agree? Would you agree with the statement that overall now, based on new evidence, that the non-coding regions of DNA function, say, much like an operating system in a computer, right? It's directing timing, expression, regulation, and use of the other information or the data files that actually code for the protein. So, like, with natural selection's limited foresight, how did this computer-like code evolve? And how is that scientific? Like, if you go back to testable and falsifiable predictions, I mean, do you have any answers to that at all?
DNA is pure chemistry. Everything about DNA works within the bounds of chemical laws and everything we know about chemistry. So there's nothing about DNA that we wouldn't expect. Going back, it's all about the origins of DNA, because everything else is explained purely by the concept of chemical laws. So unless you're asking for the origins of it, I don't know what the problem is.
I would just say the building of a genome, say, from the single-celled organism. And I guess if you're talking about DNA chemistry, if we look at something like alternate splicing, which I think clearly shows design way beyond what evolution could do, how did each exon learn how to manufacture different proteins? Also, why are there bits of sequences teaching and regulating the exon? So it just seems like it's so much more than just chemistry. And I guess I'm just using the example of alternate splicing for now. Go ahead.
DNA is like an old football. It's a bit of a mess, really. There's scratches on it, scrapes. Bit of the fabric has worn off and disappeared. There's bits of grass stuck in it. DNA is a mess, and the only reason that can really be explained is by looking through the DNA of a whole host of different organisms and seeing how they compare, which bits are the same, which bits have changed, and comparing that to morphology, to the animals we have, how we see things today. That I don't understand what is you're asking, really, apart from that. How it's formed, how all these things came together. You're asking a very vague question of, I don't understand how this works. Tell me how.
I think I'm just saying that based on and in light of all the evidence about DNA function, it seems like we're dealing at this point with a highly compressed DNA code beyond the best computer code. We know we write books. We don't write books that can be read both forwards and backwards. So if, say, natural selection mutations had to build this genome, and I'm not specifically talking about abiogenesis, of course, but if evolution is true, given the millions or billions of years of evolution, I don't see how evolution could build such a highly compressed DNA code. Is what I'm saying. Like, do you find it more plausible to say there was no designer? I guess would be the best question in regards to that.
Put it this way. As I mentioned, there is nothing in DNA that doesn't follow the laws of chemistry. Therefore, we've got no reason to suppose it was something supernatural that doesn't follow the laws of chemistry that could have brought it about. We have to assume that because it all follows laws of chemistry, that it all follows laws of chemistry, and that's how it formed. We can't just say, oh, this is too complicated, therefore God did it. We can't do that. It's just not feasible.
But if DNA is a mess, as you say, how then does it produce, just say us, for example, so well? Like, for example, Hox genes?
Because when it doesn't produce as well, those organisms die.
Time. Sorry, I gave you a message in the internal Google chats, and then I also tried to hold up my finger. I hate to cut you off, Standing for Truth, but
That's okay. That's okay. Sorry, but we could probably go on with that forever. That was fun.
No problem. So thanks for your patience. And then we will give Adam, or Steam Driven, his 10 minutes to cross-examine Standing for Truth and resetting the clock. The floor is yours.
Okay. Good starting point. Can you give me the different process in macro to micro evolution? What process is different?
So I would say if we're looking at micro and macro evolution, I don't personally like to use those words, because even in regards to our model of, say, created heterozygosity, right? God created, let's just use Adam and Eve, for example, with pre-existing DNA differences. So through processes like recombination, gene conversion, I mean, that would provide many new varieties quickly, since those differences are already built in. So I mean, certainly in regards to the biblical based model, I mean, we're going to predict change, okay? And evolution means change over time, change in allele frequency in populations over time or generations. I think it just comes down to whether or not there's a limit to that change. So it's hard to say exactly what the difference between micro and macro is, because like I said in the opening, like that type of micro evolutionary variation where you get, a change in the frequency of the expression of different traits, I'm not disputing that, right? Because that does explain the survival of the fittest, but just not the arrival of the fittest. So I think it comes down to whether or not there's limits and how far you can take that change. Are dogs and bananas related or through common ancestry? I mean, I think there'd be a limit there.
Okay. So would you consider speciation to be part of micro or macro evolution?
I would say according to the biblical based model, speciation, say from shifts from heterozygosity to homozygosity, because that's how we would explain the rapid speciation since creation and since the flood. So speciation is important, and there's been documented cases recently. Actually, Dr. Nathaniel Jensen wrote a paper on it, where in real time, finches, it was observed that there were shifts from heterozygosity to homozygosity due to inbreeding, leading to a new species of finches. So that's actually what we would predict based on pre-existing heterozygosity, created heterozygosity, I should say. I'm not against that. And I wouldn't say that that's macroevolution, because I mean, there's still finches, there's still birds, but the change we've seen in that allele frequency in those populations of finches is expected and predicted under our model. So I think I wouldn't say that that's macro though.
Okay, next question. If we go back to my bottles on the wall example, would you consider that an increase in information?
Can you, I'm looking at my notes here. I have a lot of notes on everything you said.
Okay, yeah, I basically said you have 10 green bottles to start with. Then there's a mutation where one of those bottles becomes blue. Then you have another mutation where the entire sequence is copied. So you've got 18 green and 2 blue. And then there's another mutation where there's 1 red, 2 blue, and 17 greens. Is that an increase in information?
Well, it sounds like it's because what I was saying, shifts from heterozygosity to homozygosity was leading to speciation, say in a real-time example of these finches. So in your example with the bottles, I can't see what's going on a genomic level, on a DNA level, to see if it is a loss of information. Because if a lot of the examples I see of, say, speciation beneficial mutations, if it is decay of prior information, I don't believe that's going to take your fish to fisherman. So it's hard to say. I get your analogy with the bottles, but If you could reiterate the question a little bit differently, I mean, how can I conclude if it is an increase in information?
The analogy takes single point mutations, so the green bottle will change to blue, and polyploidy, which is the entire set duplicating, which we do witness. And it was just an analogy to say replace, I don't know, chromosomes with the bottles, and those are things we do see, we have seen. So I'm just asking whether that's an increase in information.
I would say that it's, let's say gene duplications, for example. I think, and we might be able to agree to this, Adam, I think gene duplications are almost universally deleterious. So say a few rare beneficial duplications, I don't see how those are going to be able to offset the many accumulating deleterious duplications, let alone all the other accumulating mutations. And with your bottle colors, those color changes in regards to our model, those are pre-programmed in our DNA. So that information is already present. There's no new novel and meaningful information added. And probably, like all examples of beneficial mutations, it probably is decay of prior information. Does that help answer your question?
I mean, I would disagree on it, but I'd like to ask another question.
Of course.
Got about 4 minutes left, and it's nice to have these little discussions, and they could lead on from there. But my next one was, how do you explain the gradual movement of marsupials from North America through South America, over Antarctica, and into Australia?
Okay, so actually, can you repeat that? So the gradual geographical distribution of marsupials?
We find fossil marsupials ranging from North America through South America, over Antarctica, and into Australia. And the way we date them shows that it happened over time. So it lines up perfectly, moving from North America through to Australia. Can you explain that?
Of course. Like, I would say, obviously, if we're looking at, so you mentioned the fossil distribution of these marsupials. I mean, short answer would be, post-flood ice age, post-flood environmental conditions, because we look to the flood to explain the fossil record. So if we actually look at the upper layers, because you're talking about the upper layers where we're observing these marsupial distributions, correct? The fossils?
They do come from different layers.
Okay, so I would say that the layers that we see them in, based on our model of post-flood ice age, we see in those layers post-flood diversification and dispersion, and I think it's readily explainable through. I'm not sure if you've read much, creation literature, technical papers, but we say that it's explainable through land bridges, floating mats during the ice ages, right? And we can see that animals can be distributed around in very natural means, even in real time, say during cataclysmic events. So given a flood model and flood geology, I don't see a problem in that geographical distribution. Go ahead.
So you say that marsupials went from the Middle East, they traveled to North America, then down through South America, then over Antarctica, and then to Australia. Because we know that no records of marsupials being in North America or Antarctica have been found by humans in recent times at all. So say, give it 1,000 years, max. Is that possible?
So 1,000 years since the actual post-flood.
Yes, since the flood.
And you're trying to think, and you're saying that the distribution of these marsupials is conflicting to. Yeah. And based on the remodeling of, say, the Earth post-flood, well, for one, I know you mentioned, dating methods. I mean, I'm sure that could go on a rabbit trail, so we won't go on that. But I would say that there's a lot of assumptions and guesses in there. So, I mean, for me, I disagree that would be reliable. But yeah, ice age producing land bridges to cross and the distribution that you see. But the thing is, these animals, thousands of years ago, based on our model of pre-existing heterozygosity, I mean, the variation, the biodiversity, I think would be even in excess as compared to what we see now. So yeah, are you saying that there's a lot of variety in these marsupials in these geographical related areas?
Yeah, they're not the same as today's marsupials.
Yeah, and I wouldn't expect them either, because shifts from hetero to homozygosity for us in explaining speciation, I mean, post-flood land bridges, post-flood environmental conditions, because you can't look at the Earth now and assume that that's, you know, exactly the way it was before. So I think that is a plausible explanation for the geographical distribution of not only marsupials, but all other life and diversity that we see as well.
Okay, one more question to finish us off.
Yeah, of course.
What's the point of a skink with stumps? I mentioned earlier a skink that has merely a couple of stumps near the front of its body that have no purpose whatsoever. What's the point of it?
I'm sorry. It's a couple of stumps in front of its body that has no purpose?
Stumps. They've lost the claws. There's just a stump on either side.
Well, I know you mentioned, because you know, I would say a loss of information. You know, the evolutionists will use a lot of examples of losses of information as if, hey, lose everything and we'll gain it all. But in regards to that exact reason as to, I mean, if it's a specific mutation that made them lose the information, and it's a deformity, is what you're saying, correct?
It's a mutation. It's not a deformity. No, it's an actual species of skink. I forget its exact name, but it's a species that has stumps.
I mean, maybe we don't know the purpose yet. I mean, for example, how many vestigial organs were, you know, listed even 100 years ago? I think there was 140. Now they're all known to have a function. Now we're seeing this in the DNA language as well. So do we know, and do we have conclusive evidence that it has no purpose?
Time.
They're pretty useless. We'll finish there.
Excellent. So thank you